Hi, here are the notes for section 10.8, equations of circles. Um, this is a good algebra heavy section. If you've not been a fan of all the theorems in this chapter and all the definitions, good news. Really all you've got is a formula, that's about it, and a couple of parts to it. So it's a nice kind of easy break at the end. Although that doesn't mean it's not important though. This actually is very, very important. You'll see it again next year in Algebra 2. If you take pre-calculus, you'll see it there, and really basically pretty much any math class now, it seems like you'll spend some time talking about circles to some degree. And so this is the way to graph them to find their equations so you can plot them out. Let's see. Well, we've already written equations about lines using information from their graphs. Today we're going to write equations of circles, and and then we're going to graph a circle on a coordinate plane. So first of all, I got to figure out how in the world would one come up with the equation for a circle. So that's what I'm going to go through right now. So how this works actually is the distance formula. It's the easiest way to say it. What we set up is the distance between the 2 points here of hk and xy. Well, distance formula says distance is x2 minus x1 squared plus y2 minus y1 squared, and they take the square root of all that. Well, in our case, the distance between these 2 points is the letter r. So r is the distance. And then I got to do the difference in x and y. Well, or x and x. Well, that's x and h, so x minus h squared. And then y and k, that difference, so y minus k squared. And it's the square root of that. And then the last part of this says, well, this distance could go either way. I don't have to worry about it going one direction. So let's square both sides to get rid of that square root, and that'll also take care of that problem of which direction am I find the distance between. So I get r squared then equals x minus h quantity squared plus y minus k quantity squared. And basically just end up swapping these. This isn't terrible to write this way, but for some reason it's preferred to do this. Oh, and one thing I just realized I really wasn't covering. X is a point, xy is a point on the circle. Okay, that's sloppy, but xy is the point on the circle. Hk is the center. Okay, so xy is just some random point on a circle. It's going to be letters in this case. Hk will be the number. So just a real quick example: if the center were at 2, 1, and r is the radius were 3, it would be x minus h, which is 2 and 1 for k. So x minus 2 squared plus y minus k, well, k is 1. And the radius is 9, so 9 squared. Or, sorry, radius is 3, so 3 squared. So our equation would be this. X minus 2 the quantity squared plus y minus 1 the quantity squared equals 9. Okay, so let's go back to the sheet here then. Just kind of run through that, and again, this is the standard form of the equation of a circle with a center at hk and a radius of r is x minus h the quantity squared plus y minus k the quantity squared equals r squared. The standard form is also called center radius form. Okay, but standard form is what we generally call it. So here's the first question. Write the equation of a circle with a center at 3, -3 and a radius of 6. Alright, so let's take a look at the problem then. Oops, wrong button. I do that all the time. So, yes, equation of a circle with a center at 3, -3 and a radius of 6. So this is h, that's k, that's r. So the formula is x minus h squared plus y minus k squared equals r squared. Well, h is 3, so it'll be x minus 3 squared. Y then minus, well, k is -3 squared. And r squared, well, that means it's 6 squared. So x minus 3, y plus 3, 6 squared is 36. Okay. And there we go. That's the answer to that problem. X minus 3 the quantity squared plus y plus 3 the quantity squared equals 36. Now if you want to see what that looks like, real quick. Come on, computer. There we go. There we go. So I just plugged the equation in, x minus 3. Just type it in. Squared plus y plus 3 squared equals 36. There we go. There's our circle. Okay. Let me move this guy around. The center's at 3, negative 3. There's the point. Oh, dang it. I messed this up. Sorry, I typed the wrong thing in. This says x plus 6. This should be x plus 3. Silly me. There we go. That's better. And then if I just put a segment on here, and then have it tell me, well, it tells you right here, here's the distance, a is 6. So there we go. There's my circle. Okay. All right, next example. Write the equation of the circle graphed to the right. All right, well, we already got the graph here, so our job is to figure out the equation. So give me the equation. All right, so let's take a look at the example. We need to know two things in order to find the center of a circle: the center and the radius. And let's see here. In this case, they've kind of given us some extraneous information. They gave us the radius here. It's 2. So r is 2. Now they've told us point 3, 3, but that's not the radius. That's just that's at the center. That's just some point off the side. The center is right there at 1, 3. Okay. So now we can just plug it into the formula. X minus h quantity squared plus y minus k quantity squared equals r squared. So x minus 1 squared, y minus 3 squared, r is 2 squared. And then 2 squared is 4. There we go. Equation of the circle. Last problem for this section. Again, it's a short section. There's not a whole lot to go over a lot of times on this one. Write the equation of a circle that passes through this, or has its center at negative 3, negative 2, and passes to the point 1, negative 2. Okay, so this one's a little tougher because I don't have r. If I go to set up the equation of it, I would get x minus negative 3 squared plus y minus negative 2 squared equals r squared. I mean, this is h, this is k. So what I have is x plus 3 squared plus y plus 2 squared equals r squared. Well, what can I do here to figure this out? Well, they did give us a second point. And in the second point, here's an x, here's a y. So let me plug 1 in for x, let me plug negative 2 in for y, and that'll allow me to solve for r over here. Now, we get then 1 plus 3 squared, which is 4 squared. Negative 2 plus 2 is 0 squared. So that's great because that drops off. So I'll get then 16 equals r squared. And some of you will be tempted to go, oh yeah, take the square root, take the square root. 4 is r. Great. Now you can plug 4 back up into here. But what am I going to do to that 4? I'm going to square it. And you know what? To save you some time and energy, I didn't have to do that because right here, I knew what r squared was equal to. It was equal to 16. So I'm lazy, and I will stop a problem when I do this one right here because I already know what r squared is equal to. 16. So I don't even mess with this. So I get x plus 3, y plus 4, y plus 2, and then 16. And there we go. So I can find the equation of a circle if I know the center and a point that's on it. And that's the section. So any questions? Okay, see you tomorrow.